All right, so this is the final lesson. This is should be video 3 of 3 for 1.3. And we're going to take a look at a little bit more at composite objects. We started looking at those the other day, but composite objects, as we've learned, are objects where they're composed of different separate objects that are kind of stuck together, okay? And so, is everyone paying attention? Everyone got their notes out? Please get your notes out. Don't work on your worksheets right now. Just make sure you're following along with the notes. So a composite object is made up of, or composed of, more than one separate object. Okay, that's what a composite object is. It's more than one object kind of stuck together or attached somehow. It may be composed of more than one of the same type of object. So we could have many different identical cubes, let's say, or we could have a collection of rectangular prisms. Maybe does anybody know what these are called? They're circular prisms. Those are called cylinders. Right. We're going to learn about those. I think later today, we'll learn about how to find the surface area of those, if you don't know already, and different things like that. There's also things called triangular prisms, which I believe we'll get to today. Let me see. Is it this one? Yeah. So this is called a triangular prism, and of course we have our cylinder there. Another triangular prism. So we're going to look at finding the surface areas of these objects as well. But for now, let's get back to composite objects. So we started this the other day. This one's going to be one just like the example we did yesterday. So let's keep going with this. This one's maybe a little bit easier to figure out because it does have the division here, right here in the middle. And we don't have to determine as many side lengths for this one. So this one's an easy example. So the surface area, and you can go just area, or SA is surface area, you'll see that a lot, is going to be composed of all of the different areas of all of the different faces. And today we're going to take a look, again, we're going to work with some cubolinks and give you an opportunity to do that if you want to. And I still have my little bench from yesterday's example there, and this one here, okay, kind of looks like this, I guess. Kind of looks like this, right? So if you look at it from this way, it's kind of like a bench that goes like that. Okay, so kind of like that. Now, yesterday we labeled the sides, or the sides that we could see, and those are important. So let's go area 1 here. That looks like an easy one to figure out. How about area 2 over here? Area 3, area 4, and area 5. Now we know that there are other areas as well that we can't see, right? Well, maybe we'll deal with those in a bit. And what we also want to realize is that we can assume that these are 90-degree angles, and so the back sides of the shape are going to be identical to the front sides, okay? So we'll get to that here in a second. Let's figure out what area 1 is, okay? So the surface area is going to be made up of all the areas. So I'm just going to say all areas added together, okay? And the areas that we're talking about are the areas of the faces, okay, of the faces or the sides of this object. So all areas added together. All right, so area 1, okay. Well, I guess it's right here. What's the length of this one? This square is 4.4 centimeters. And to find the area of a square, we have to find out what the height is or the width is. So what is this side? Yeah, it's the same. It's 4.4 over here. So we basically do 4.4 squared, or 4.4 times 4.4. You can get your calculator out and do this on your calculator. That's no problem at all. 4.4 times 4.4 is 4.4 squared. Good, 19.36. Heard some of you say that. So 19.36. So we'll have to keep in mind that all of these units are centimeters. That's great. So the areas for each face is going to be centimeters squared. And when we add up all the areas, the total area is also going to be centimeters squared. All right, let's do area 5. I'll tell you why I'm going to do area 5. Because area 5 makes up this front sort of whole face of this object. You see that? So area 1 and area 5 added together gives us this front face, which that's going to be helpful in a second. So area 5 is, it's easy right there. Look at this side is 5.6. So we'll go 5.6 times 2. Notice I'm not using the x's for times. Please get away from that habit if you're still doing that. I notice some of you are still doing that in your work. Please do not put a little x for times, okay? Just don't do it. Because in high school now, we use x a lot for a variable, for an unknown variable. And you're going to get really mixed up if you times x in a problem, okay? It's not going to be good. So don't use this times anymore. You can use a little dot, or you can use no dot like I'm doing there. That means multiplication as well. So in high school, you can write it like this. So 5.6 times 2 is going to be 11.2, I think it is. 11.2. And that's going to be centimeters squared, right? Okay. Now, why did I highlight area 1 and area 5? Why do you think that's going to be important? Yeah. Can't hear you? Okay, area 1 and area 5, yeah, constitute or make up a bigger shape, this one here that I've highlighted, yeah. And so why is this one important to this shape, do you think? Oh, go ahead. Yes, for the other side that we can't see, right? Okay, so this is going to be really hard to draw, but the other side that we can't see is going to be like this. Okay? It's going to be like this, and it's right here. Okay, so we can't see the other side, but that's what the other side is. It's going to be identical. So guess what? We can multiply this times 2. Okay, so we can go area 5 again, 11.2. Area 1 and area 5. So we'll go this one, right, times 2. So this is let's say the back sides, okay, the back sides. So 19.36 and 11.2, we're going to add those again, okay, multiply them by 2. So I'll maybe let's put a little circle around each one that we're going to add up, okay. I don't normally circle things that aren't my final answer, but we'll just keep track of all of the areas, okay, that way, and you can do that if you want. Okay, so we have the front side, we have the back side. That's amazing. Now let's work on the other sides that we see here. I'll try and erase all my markings here without erasing too much. Okay, so we've got area 5 covered, area 1 covered, and the back side. So let's go area 4 here now. What about area 4? Doesn't matter which one you do first. So what is this length here of area 4? It is going to be 5.6, right? Same as the side below it. And then what is this side here? Yeah, it's going to be the same as this one. And it's the same as this one, same as this one, and same as that behind there that we can't see. So yeah, 5.6 times 4.4. Any questions on that? Hope everybody sees that. So this is 4.4. All right, that's awesome. What is that? 5.6 times 4.4. Anybody got that? Say again? 24.64. 24.64. Thank you. Centimeters squared. All right, so we'll add up this one as well. So keep track of that. Okay, A3 is going to be 4.4. That's this side here, and 4.4 again. Lots of 4.4s. I like that. And we've done that equation already. That's 19.36. Okay, so we've got 4 taken care of. We've got 3 taken care of. Area 2 we haven't done yet. Area 2 is going to be 4.4 times 4.4. Wow. Yeah, that's right. It doesn't look like a cube, but I think it is a cube, right? Because all sides are the same for this big one right here. Okay, so 4.4 times 4.4, 19.36. And that's area 2 we've got. All right, so what are we missing? Are we missing something here? I feel like we're not quite done yet, are we? Yeah, we're missing the bottom. Now, let's be smart about the bottom. What is the area of the bottom? We actually have already calculated. We already have enough information for the area of the bottom here. What is that going to be? Anyone see on this diagram what that's going to equal? Yeah.
A4 plus an A3.
Thank you. A4, the top piece there, plus A3, the other top piece. So if you look down on that from above, all you see is A4 and A3. So just like this here, okay, like this. If you look down on from above, you see A3 here and A4 right here. A3 and A4. If you turn it upside down, that's the same, A3 and A4. So it's the very same as A3 and A4. So let's just add those together some more here. So where are we? So we also need another A3. So I'm going to put 19.36 and 24.64. So this is the bottom. Are you good with that? Now, we're still missing one, I think.
Yeah.
Aren't we? Which one are we missing? Well, we did the back, we did the top, we did this side, but I don't think we've done this side yet, have we? No, we haven't quite done that one yet. So that's a 4.4 times 2. We haven't done that one. So let's call that one a, what are we at, 6? Oh, we got an A5 already. Let's do an A6. So A6 is 2 times 4.4, which is 8.8. Okay. Now, might be a little tough to count all the sides on this diagram, but on this shape, let's count all the sides that we would need to figure out. So I'm going to go 1, 2, 3, 4, 5, which is, okay, 6, 7, 8. Now, we don't have them all completely separate because we combined the back and the bottom. So I don't know, does that make sense? 1, 2, 4, 5, 6, 7, 8, 9, 10. If we count this as 1 and this as 1, I think we're good. But final count, anything we're missing?
What about the side? Because like the two shapes are not the same level.
Okay, so we're still missing one piece, aren't we? The piece that we're missing is, let me just get this the way you can look at it here. So the piece that we're missing that we can't see is this side right here. Okay, let me show you. So from here, on the back, on the side that we can't see, so this is like the side that's behind there that we can't see, that's projecting above this surface, right? And it's around the back side there where we can't see it. All right, very good. I think that's the last one. I think that's the last one that we're missing, but we still need to get this guy. So how do we do that one? That's going to be A7, let's say. A net diagram might have helped here. I'm not sure. A net diagram might have been pretty handy. But how are we going to find? Okay, so the top edge is 4.4, right? The top edge is 4.4. What's the height here? How do I find out this height? Okay, I heard somebody say 2.4. How'd you get 2.4?
I took the overall height,
Overall height here, yep.
and then I subtracted the other height, which is from.
Subtracted this height.
Yeah.
Excellent. So we've got the overall height minus this height here is what's left over. So 4.4 minus 2 is 2.4. Very good. Okay, so 2.4 times 4.4 is 10.56. That's a lot of sides, isn't it? Yeah. So that's a tough one to keep track of. This might help. Making the shape kind of like this might really help. The cubolinks obviously will only be able to do rectangular prisms, not the triangular prisms or cylinders per se. But they might help for a lot of these questions. Okay, so we still need to add them all up. So surface area total, yeah?
How
Nope.
did you do 4.4 times, aren't you supposed to do 4.4 minus 2?
Yes, that's the 4.4 minus 2 is this side, but this right here is 4.4. So the length here, the longer side, is the same as this, 4.4. Yeah. So that's this side, and then in red here is this side right here.
Okay.
Well, is there 9 sides? Let me see. Somebody asked a question. What's tough is that in doing this, the back, okay, and the front, is that 1 side or 2? So we've put the front as, I've counted as 2 sides here, you know, this one and this one. But the back, you know, so I think we've got it. I think we've got all the sides now. So it depends how you count the front here, this little L shape. If that's 1 side, then this A1 and A5 would be just 1 side. And then the back would be just another side, right? If we did it like that. The bottom would be a whole side in itself. So I guess just be consistent. Try and make sure you've got every side accounted for as best you can. All right, let's add them up. Please, everybody with a calculator, add these up so we can confirm that we have the right answer. Okay? I'll let you guys do that. And let me know what the answer is going to be. All right, so the majority says what was it again? 187.84. And what are the units going to be for that? Centimeters squared. Okay. Let's turn to the last page here in our notes. This is a local hockey rink, and it's shown in the diagram here, and it needs to be painted. So determine how much paint you will need to purchase to paint the hockey rink here. And we will not count the whatever this is, a window or maybe the doors. We will also count the paint for these. We won't subtract those, okay? Just so we have a little bit of extra. What we're going to do is we're going to find the area of all the sides of the hockey rink, and we're going to add those together. Now, in a question like this, okay, it should be known, like the last question, we found out what the surface area was for the bottom, because this is just a 3D object in space. But when we have questions that are real-life questions like this, we obviously know that we're not going to have to paint the bottom of the skating rink, right? It's sitting on the ground, so we don't need paint for the bottom, so we don't have to count the bottom. All right? Okay. So let's label this area 1, area 2, and we're going to go area 2 times 2, okay? Because we have the front and the back that are the same. We're going to have, so here I'll just draw some dotted lines. Area 2. We're going to have area 3 here. Area 3, oh, my computer is... area 3 is this side, so we'll go area 3. We'll do that one times 2 as well for this back side, hey? Then we're going to have to focus on the little, like the porch here where everybody kind of comes in. So we're going to have area 4. Can somebody grab that door, please? Thank you. Area 5. We're going to have area 6. And then the back side is going to be the same as area 4. So we're going to go area 4 times 2. Okay? Now this will take some focus and concentration when you're doing this. So don't do this while you're talking about movies or your weekend plans or something, okay? Focus, just do me a favor and focus on this so you don't miss up on something. It's already hard enough for me when I'm trying to ask you guys questions and see what you're doing and see if you're understanding, and I'm back and forth all the time too. So it's tough enough for me to keep track of all this. When you guys are doing this for the first time, you're going to want to make sure that you've got some quiet and you'll be able to focus on this, okay? Because there's a lot of things you got to keep track of. All right, having said that, do we have all the sides covered here now? We have front and back, we have side and other side, we have top, and we have front and back of this little porch there. We have the top and we have the front side. Okay, so area 1, what's going to be area 1? That's going to be 65 is the length here times the width of 45. Good, 65 times 45. So 65 times 45, you said was 2925. I like it. 2925. Now that's going to be square meters. That's a lot. It's a big building, hockey rink, right? Okay. That's okay. So area 2. All right. What's area 2? That's going to be 65 times 15. 65 times 15. And we're going to go times 2 for the front and back. So actually, just wait. Let's do it one at a time. Area 2 is 975. And then we're going to go times 2. 1950, you said. That's right. 1950. So sometimes when I'm doing my work, I kind of, if I have numbers that I'm going to need to pay attention to after I'm done all my work, I sometimes do like a little L like this. Instead of circling a whole bunch of things, because like I said, I like it when you just circle the answer. That's what you should do, is just circle the answer or just square the answer. So in the question, this is what I do when I do my work. When I do exams and stuff like this, this is how I show my work. So these are little numbers that I'm going to need later to add up. So I'll just highlight them a little bit by doing something like that. Okay. Area 3. Area 3 equals what? What's that going to be? That's going to be 15 times 45. And we're going to do front and back, so let's find out what that is, and then we'll multiply that by 2 in a bit. That's going to be 675. You guys get that one? So, oops, 675 times 2 is going to be 1350s, right? Awesome. So we'll keep track of that for a little bit later as well. All right, we're knocking things off here. That's gone, that's gone, that's gone. So let's focus on the little portion there in the front. So area, I guess 4 is next. So that's going to be pretty easy. 6 times a height of, yeah, it says 5 there. So that's going to be 30. 30 times 2 is going to be 60. All right, so 60 square meters. Area 5 on the diagram is going to be found by multiplying 10 times 5. Good. That's going to be 50. Do I need to multiply that by 2?
No.
I don't need to multiply this by 2, and I'll show you why. Because the back side of the porch is squished up against the rink itself, right? So we don't need to paint that part that's stuck together. It's not exposed to the air, so we don't need to paint that part. So we're just going to do 1A5. Yeah?
For A, like the side that has that bit on it, would we have to subtract A5 from it?
Okay, so this part right here, yeah, we're gonna talk about that. Very good. This side of the rink right here, okay. Yeah, let's talk about that right now. That's a good point. So when we're painting, if we're talking about not painting this side of this porch that's stuck to the building, then we also understand that this is covered on the larger side as well. So you have 2 options here. You have 2 options. A5 can be counted and then subtracted from the big side, okay? Or you can look at this and say, hey, I'm going to subtract A5. This is the area here on the side of the hockey rink. I'm going to subtract that anyway, so I don't even have to count it. So you could do two things. I would like you to count all the sides, and then at the end, think about, hey, is there anything that we need to fix at the end, like anything that we've counted twice? So some of you will say, when you're labeling these sides, actually A5, I don't have to count it, because if I find the area of A5 here, I'm just going to have to subtract it from the area of the side of the rink that I already calculated. So you might just axe it all together. So let's do that now. That's fine. I was going to come back to that at the end and highlight that, but I'm glad that you caught that. So let's talk about that now. So guess what? We're going to subtract A5 because it's covering part of the side of the rink that we've counted already as surface area. So we're going to subtract A5. So we're going to go minus 50 because it's covering the side of the hockey rink that we've already counted in our area. Very good. Very good. We'll take that as a hint to talk about that right now. So A5 is kind of out of the picture, right? It's kind of like we didn't even really need to count A5, but we counted it and realized that we had to subtract it from the big side. All right, so we still need to do A6 then, is that correct? Okay, so A6, sorry. I'm making this video here, but I don't want to cover the diagram up. Okay, so A6 is what, sorry, what was it, which one was A6 again? Was it the back side?
Yes.
Did we count that already or no? I erased all this. A4 times 2.
A6 times
That is the top.
Oh, A6 is the top. Okay, A6 was the top. Thank you. Okay, so we do need to count the top. So that's going to be 6 here by 10. Awesome. That's 60. Okay. Any other thoughts? Any other questions? Did we miss anything? Oh, is that looking good, or is it not sitting right with some of you? What do you think? These are all the things that I'm going to combine at the end. Okay, we think we're good to go? Let's add them up and see. So surface area total, or the amount of paint we're going to have to cover, the amount of area we're going to have to cover with paint, is going to be, let's add it all up here together. So 2975, nope, that's 25, plus 1950, plus 1350, plus 60, plus 50, minus 50, plus 60. Okay, did I mention everything? So we've got a total of 6345 meters squared. Now that is including the roof. So it doesn't say in the question whether we're going to paint the roof or not. Usually roofs are not the same as walls on the side. So usually roofs have shingles or tin roof or something. So normally you don't have to paint that. So in a question like this, if you said you're going to paint the roof as well, I think you'd be okay to do that. But also, if you said no roof, because it has other roofing on it, then we'll have to subtract this part, okay? And so with no roof, what's that? 6345 minus 2925, yeah, is, 3420? Did you guys get 3420?
Yeah.
Okay, still different than some notes I see here, but anyways, so no roof would be 3420. With the roof, if you're painting the roof, then it's going to be this much. 3360. Oh yeah, I guess if you take away the small roof too, that's the other part. Yeah, you might have to take away the small roof. That might be shingled as well. So no roof would actually be, good job you guys. That's maybe going to get me to the notes here that I have. So what's that? What's that area? That's A6 is 60. All right, so minus 60, what do we get there? 3360. That is the correct answer with no roof. 3360 meters squared. Excellent. Yeah. So like I say, if the question is not clear like that and you count the roof to paint and the question doesn't say don't count the roof because it's going to be shingled or a tin roof or that you don't have to paint, then that's fine. I'm okay with that. If you paint the underside of the rink, that's a problem. Okay? You're not going to pry the rink up, crawl under there and paint under there with all the bugs and termites and gophers. Okay? So that's not cool. But if you think, oh, it's a flat roof, it looks like it's a flat roof, maybe it needs to be, painted because we have a flat roof on the school over the gym here. And there's paint and there's rubber stuff and there's all sorts of stuff that they have to cover with material. So a flat roof, you might think, we're going to paint that. Okay, enough about that. But that's the reality of word problems, right? There are some things that you really have to think through. All right. How are you guys doing? Doing okay? All right. Now, we did start one of these pages last day. It's this one. We started this one last day, and this was the answer for this one, and very similar to one that we've done, right? What we realized that we had to do was we had to separate this front side into two rectangles here. No problem. So you know how to do that now. Before you get going on completing the rest of this worksheet, and you have to, what do you have to do? You have to pick 4 of these. I've done one for you. You have to pick 3 more to do. But before we do that, this is going to be the worksheet you're going to work on a bit later. Before we do that, I want to spend the rest of this lesson talking about some other prisms that we're going to have to find the area for, and namely Those prisms are triangular prisms, like this, and cylinders. So we talked about that at the beginning of the lesson. Let me just spend some time on these two, and then we'll kind of go from there. Whoops, let's go back up here, maybe. Let's tack it onto this page. All right, so we got a triangular prism, and then we'll deal with the cylinder as well. So we'll call this triangular prism. And if you've seen those glass prisms in science, this is the shape they're in, right? The triangular prism. Why do we use triangular prisms in science? Well, because triangular prisms, and I'll get you to sketch this out. And while you sketch this triangular prism out, I'll just show you that when light comes in to a triangular prism on an angle, that light gets refracted. That means as it enters the new material, it gets bent slightly. And when it exits the material, it gets bent again. There's a succession of bending of light, and what happens is this narrow beam of light that enters the triangular prism gets spread out, and you end up seeing all the colors of the rainbow here. And so that's why light passing through a prism is really, it's kind of bent and warped and stretched twice. So that's why these triangular prisms are pretty important in science. And if you haven't played with one before or seen the effects of one before, I'm sure you will shortly. I don't have a glass one handy here, but. All right, so how do we find the surface area of a prism? Well, I don't know if you guys have noticed, but there is a pattern for all prisms. And we've been talking about rectangular prisms, okay? Rectangular prisms. And what we've done is we have found, okay, so we've found the areas of the front and the back and the top and the bottom and the two sides. So it's been a pattern that we kind of usually start front, back, top, bottom, side, side. Now with this prism, we can do the exact same thing. All right, so I'm going to sketch the back side with some dotted lines. This is what the back side would look like if we could see it. It looks something like this. Okay. Now, if you look at that long enough, I don't know, does that look like a triangular prism that's coming out at you, or does it look like it's going back? Those dotted lines, what I'm saying is that you could kind of look at this two ways. This could be the front side that's up in the air to the right. Does anybody see that?
Oh, yeah.
And this right here would be the bottom of like a tent or something. Now, I'm going to do this. Now, if you looked at it, look at this. This is the front of the tent. And this is the side of the tent right here. And that's the back entrance. This. Do you see it now? Where this is the front and it's on the lower right?
Yes.
Anybody see that?
Yeah.
Is that kind of weird? Do you see that kind of flopping back and forth?
Yeah.
Sometimes you see things like this drawn three-dimensionally. Sometimes you see it different ways. All right. So let's do the same thing that we're doing with the prisms. And I'm going to label this area 1. And we've got area 2. Guys, pick your heads up, please. No heads down in my class, please. Thank you. I want you paying attention here. Thanks. So area 1, area 2 on this back side here, on the side of the tent, that's going to be area 3. And we're going to have a bottom. This is not a tent, so we are going to take a look at the bottom, and we will count the bottom as well. Okay? So let's do surface area is going to be area 1 times 2, right? So I'm going to do 2A1. This is how I'm going to write it for you. 2A1, because that's going to be the front side and the back side, which are identical. Got that? Plus, now, is A2 and A3, are they the same?
Yeah.
Look at this. Because this is 5 and this is also 5, A2 and A3 are going to be the same. So we could go 2A2 here. Okay? Front, back is going to be the same. The two sides are going to be the same. And then the bottom is going to be A3 here. Let's make the bottom A3. So plus A3. So we should have 1, 2, 3, 4, 5. We should have 5 sides in a triangular prism. So let's make a little note here. There's only 5 sides in a triangular prism, not 6 like a rectangular prism. All right, so let's see. Surface area. Let's do it all at once here if we can. Area 1. So we're going to go 2 times area 1. How do I find the area of the front side here? Remember, it's a triangle.
Wow.
How do we find the area of the front side? Base times height divided by 2. Excellent. So base is 6. Height is 4 divided by 2. Very good. Okay, what about area 2? What's that one going to be? I'm going to go 2 times the area 2, which is 5 times 11. And then area 3 is going to be 6 times 11. All right. Okay, so your job is to finish this this example in your notes right now as we leave, because that's the bell for a little shortened class today. And also, I want you to go back and finish where is it? This worksheet. This one. Okay, and finish this worksheet. I will have one more worksheet for you guys to work on. Actually, you know what, grade 9s, before you leave, I want you to pick up this worksheet, because you should start working on this worksheet before Monday. So you don't have to have it all done, but there are some triangular prisms, and you can try the cylinders there, see if you can figure that out, but I'll talk about that a little bit more on Monday about the cylinders. So come get your worksheets. All right, so now you know how to do triangular prisms, surface areas. We're going to talk about the surface areas of cylinders next day, okay? And so that'll be next day, and so you can work on this worksheet, get everything but the cylinders done for next day. And then video number 4 for this section, we'll talk about cylinders, and we'll get into some more of these worksheets. We'll go back to practicing with some net diagrams, and other composite objects before we hit 1.4.